Good morning or afternoon, everybody. Today we are going to be learning about isotopes, and hitting the target, I can calculate the number of protons, neutrons, and electrons of an isotope. Before we get into today's lesson, let's take 30 seconds and just review how to calculate the number of protons, neutrons, and electrons for a regular atom. Remember, the protons equal the atomic number. And for today, the electrons equal the number of protons as well. But the neutrons are the tricky one. They equal the mass number minus the atomic number, or the number of protons. It means the same thing, really. Okay, let's get into today's lesson and learn how to use these rules when we are involving an isotope. First of all, what is an isotope? Isotopes are simply atoms that have the same number of protons, meaning they are the same element, but they have a different number of neutrons. Sometimes atoms can gain or lose electrons. Or not, sorry, they can gain or lose electrons, but sometimes they can gain or lose neutrons. And what this does is it causes them to lose some of their mass. Because remember, the atom, all of its mass is located in that nucleus. And so if it's losing or gaining some of its neutrons, its mass is changing. Okay. Its mass number is changing. I'm going to be showing you guys a couple of problems today that involve something called symbolic notation. What that means is that I'm just writing all of the information that the periodic table would tell us in a slightly cleaner fashion. The mass number is always going to be the larger of the two numbers, and it's going to be located in the upper left, the atomic number in the lower left, and then of course the symbol of the element that I'm using will make up the center of our symbolic notation. Okay. All right, so this slide shows three different versions of hydrogen. We have just regular, ordinary hydrogen atoms, and then we have two isotopes of hydrogen. Their mass numbers are different because the number of neutrons they have is different. So, how do we calculate the number of protons, neutrons, and electrons for isotopes? Well, the protons and electrons, it's pretty easy. How many protons and electrons do each of these isotopes have? 1. Note that the atomic number for all three versions of hydrogen is 1. And what that means is that the number of protons they have is also going to equal 1, because the atomic number, struggle is real, there we go, equals the number of protons. And because these atoms don't have charges, the number of electrons equals the number of protons. Okay. But the neutrons are kind of the tricky ones. Remember, in order to find the number of neutrons, what equation do we use? We use mass number minus atomic number, or number of protons, because it means the same thing. So, for our first version of hydrogen, just a regular ordinary hydrogen atom, 1 minus 1 is 0. How many neutrons would the next two versions have? 2 minus 1 is just 1, and 3 minus 1 is 2. There you go. And that's how we can find the number of neutrons, protons, and electrons of an isotope. Let's try a couple more practice problems. There are a lot of different elements, and every single element, I think, has isotopes. Yeah, it does. Every single atom in the entire universe has at least one other common isotope. So, let's look at lithium, for example. Here, we have two versions of lithium. One has a mass of 7, one has a mass of 8. See if you can figure out the number of protons, neutrons, and electrons that these two versions of lithium would have. Alright, let's make sure that you guys are getting this correct. So, the first version of lithium and the second version of lithium are going to have the same number of protons and electrons because, well, They both have an atomic number of 3, and neither version of lithium has a charge. But the number of neutrons is going to be different. For our first isotope, 7 minus 3, is 4. And for our second isotope, mass number minus atomic number, 8 minus 3, is 5. Cool. Let's try one more practice problem, and we will be done for today. Go ahead, tell me the number of protons, neutrons, and electrons for these two isotopes of beryllium. Awesome. Yep, just like with the last problem, the number of protons and electrons, pretty easy. Because the atomic number is 4 and there's no charge, both of these isotopes have 4 protons and 4 electrons. The neutrons, however, are going to be a little bit different because the mass numbers are different. 9 minus 4, mass number minus atomic number is 5. And for the second one, the mass number minus the atomic number, 10 minus 4, is 6. There you go. Fairly straightforward. That is how you calculate the number of isotopes, the protons, neutrons, and electrons for an isotope. Stay tuned for our next video where we discuss how to calculate the number of protons, neutrons, and electrons for an ion. See you later. Bye.